The Agenda with Steve Paikin is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.
Decades of genetic research helped speed the arrival of COVID-19 vaccines. Tonight, we explore some of the questions such work raises. First, how are human cells used in the new mRNA vaccines? Then, does it matter who owns your DNA when it's used by medical researchers? And what can we learn from the wrongs done to Henrietta Lacks, whose DNA has saved countless lives? It's Monday, October 25th, and that's all next on The Agenda. Human cells became something of a flashpoint in the past year, cited by some as the reason they're hesitant to get the COVID-19 vaccine. With us now for the science and to clear up some of the misinformation out there, from High Park in the provincial capital, there's Dr. Janet Rossent. She is senior scientist at the Hospital for Sick Children and president of the Gairdner Foundation. Dr. Rossent, it's good to have you on TVO tonight. How are you doing?
I'm doing fine. It's great to be here.
Great to hear. Some people apparently are hesitant or will not take the COVID-19 vaccine because they believe that the vaccine contains fetal cells from abortions. So let's get that straight once and for all. Is that true or false?
That is false. There are no fetal cells in any of the COVID vaccines.
So if you don't want to take the vaccine and you're using that as the reason why you don't want to take it, you're all wet on this one. Is that right?
You are all wet if you think it contains fetal cells. It is true that some of the research behind the vaccines used cell lines derived from elective terminations of pregnancy. Cell lines generated many years ago that turn out to be very good at producing proteins and viruses that are needed to help develop vaccines, but there are no fetal cells in the vaccines themselves.
Okay, can you pursue that a bit for us? How are cells from aborted fetuses used in labs now?
So the fetal cell lines that were derived many, many years ago have been grown in culture for many generations. They divide indefinitely. They are nothing like the fetal cells that they began with. But they're, as I say, they're very good, they're very stable, and they produce some of the viruses and the vectors that are used to make vaccines. The messenger RNA vaccines that we know most about, the Moderna and the Pfizer-BioNTech ones, the fetal cell lines were used a little bit in the development, but when you produce the vaccines, they are made out of nucleic acid, and they don't have anything to do with fetal cell lines. The AstraZeneca cell line does use a cell line that was originally a fetal cell to produce the vaccine. But again, no fetal tissue is actually in the vaccine itself.
And are fetal cell lines ever injected into people?
No. No. These are research tools, technology tools to produce vaccines. In fact, they have been used for many of the vaccines that we're familiar with today that are saving lives. Rubella vaccines, rabies vaccines, some of the chickenpox vaccines, hepatitis A, all were using these cell lines that were originally, many years ago, derived from fetal material.
All right, let's talk about another kind of stem cell, embryonic stem cells. First of all, what are they?
Well, they also don't appear in vaccines, for sure. But embryonic stem cells are quite a different story. They are cell lines that are derived from early human embryos at the time when the embryo has about 100 cells. So it's the size of a speck of dust. And at that stage of development, the embryo hasn't made any decisions about what it's going to do. So the cells are what we call pluripotent. It contains these cells that can make every cell type in your body, because that's how we get from an egg to a person. And it turns out, first in the mouse and then in the human, that people were able to take these embryos at that stage and generate permanent pluripotent stem cell lines. And they are derived in humans from embryos that come from in vitro fertilization clinics, embryos that would not be used for reproductive purposes and have been donated with permission for research purposes.
So do you get all of yours from IVF clinics, for example?
Well, so most of my work is mostly with mouse embryonic stem cells, but in fact, the stem cell lines, there are human stem cell lines that have been approved in Canada, and we do some research with those. And yes, they were all, and there aren't a lot of them, there are few cell lines that are used quite a lot, and they were derived from in vitro fertilization clinics, yes.
And let me just clarify again, and why would you use this particular type of stem cell line?
Well, these are the cells that have incredible potential for regenerative medicine. Because they can grow forever in a petri dish, you have an endless supply of cells that can make nerve cells, that can make muscle cells, they make heart cells, they make pancreatic islet cells that produce insulin, they make the cells in the brain that make dopamine. So these cell lines can be used to generate cells that can help treat serious degenerative diseases.
So they're extremely useful for your purposes.
Yes, well, not my purposes, hopefully for many people all over the world. There's a huge amount of activity in this area. But of course, it is controversial. They come from embryos. And so there's another kind of cell line that has many of the same properties. It's called an induced pluripotent stem cell. And they were produced first by a Japanese scientist, Shinya Yamanaka, in 2006, first in the mouse and then in the human. And he showed that you could take a skin cell and add back some of the genes that we and others had shown were important for the early embryo, add them back to these cells and essentially turn back the clock. And then these cell lines behave like embryonic stem cells. So now you don't have to use an embryo. You can get the same kind of potential in these cells by just taking adult skin cells. So this has really been a big boost to study these cell lines and also to study disease, because it means that if you have a genetic disease, you can make induced pluripotent stem cells and study that disease in a petri dish and develop new therapies. So these are incredibly powerful cells.
Okay, so you got to say their name one more time. I always call them IPS because that acronym is easier than the whole thing. But what are they actually fully called?
Induced, because they've been induced by adding these genes. Pluripotent, because they have many potentials. And embryonic stem cells.
Okay, let's do a little comparing and contrasting here, because the first type of cells that we talked about off the very top, you said come from generations ago. The embryonic stem cells, are they also from generations ago?
Well, they are now. So some of the embryonic stem cells that are being used quite extensively worldwide, there's really only a few cell lines that have been stable enough to be able to be passaged for many generations. And we're now looking at the first human embryonic stem cells were derived in 1998. So it is quite a long time, and they have been grown not continuously all that way, but they've certainly been through many generations in the petri dish. They just keep dividing.
And IPS stem cells, are they the same as well?
Yeah, they can divide indefinitely as well. But they were later, so they're 2007, so they haven't been around quite as long.
Gotcha. And have they come to replace embryonic stem cells in your lab use?
It's a mixed bag. There's no question that the iPS cells come with less concerns about their origins, and they do in some cases have special properties because you can derive them from humans with different genetic backgrounds. So there's a lot of use of iPS cells, but embryonic stem cells are still used in many labs because they're the sort of gold standard. We know where they came from. They came from the stage where we know what the cell behavior is, whereas the iPS cells, you've artificially made them. And so it's still a little bit, there are many iPS cell lines, but trying to work out which are the best ones to take forward for treating patients is still embryonic, I would say.
All right, one more question on this line, and that is, I suspect there are many people watching this right now or affiliated with this issue who have been asked to store the umbilical cord blood when they have a baby. So tell us about how that is used.
Yes, so from the umbilical cord, you can isolate stem cells, but they are not embryonic stem cells. They are not cells that can make every cell type. They are actually the stem cells that make your blood. So they are like bone marrow stem cells. They can be used for bone marrow transplantation. But really and truly, what we need to do, the best way to store umbilical cord blood is to store it in a public cord blood bank, the same way we store blood and we store other kinds of cells. Because if you put your baby's cord blood into a public cord blood bank, that can be pulled by anyone who needs it, a child who needs it later on. And you can go back in and pull out cells for yourself. But a single cord blood is, generally speaking, not enough to treat one person. So a private bank that says, I'll store it just for my child, is not the best way to go.
You prefer the public situation?
Absolutely.
Yeah. And is it the same thing if you're, for example, getting a blood transfusion, or you need blood? There's a match that has to happen, or it's no good. Is that the same thing here?
Yes, yeah, you have to, absolutely, it has to be matched.
Gotcha. All right, we've talked about all these different kinds of stem cell lines. Let's talk about how they're employed. And that is, how many of the treatments or products do we use which employ these cells in their research and development?
So we're talking about fetal cells or embryonic stem cells?
Yes. Well, okay, you tell us. I mean, both, I guess.
Well, as I say, fetal cell lines are used still quite extensively for research purposes and to some degree for producing vaccines. Embryonic stem cells and iPS cells are moving now towards clinical trials. We are seeing the first clinical trials for using embryonic stem cells, or products of embryonic stem cells, I should say, for treatment of diabetes, Parkinson's, macular degeneration. Those are ongoing clinical trials. The diabetes one, there's quite a lot of researchers involved in that in Canada, for example. Parkinson's in Japan and in Europe, and macular degeneration, also Japan, US, and Europe. From taking embryonic stem cells in the Petri dish, differentiating them into the right cell types and putting them back in patients. So these are early phase clinical trials, but some of the data is really looking quite promising.
Let's understand what that means. Early phase, quite promising, meaning we're still probably many years away from touchdown?
Well, this is always, of course, a difficult question, as you, I'm sure you're aware. The early phase trials are really trying to say, are these things safe, and do we see any efficaciousness? And the answer is for some of these, that seems to be the case. I think some of the ones like macular degeneration, when they're actually replacing the pigmented cell in the eye which degenerates, look as though if those work, it could be relatively quickly turned into a clinical use as opposed to just a clinical trial. So we're looking at, you want me to guess? I mean, I do think we'll be seeing much broader clinical use of some of these approaches within 5 years.
But if I were to put you on the spot right now and say, what is the one thing that you hope all of this specifically will lead to as it relates to disease X, Y, or Z, what would you say?
Well, I think that the power of embryonic stem cells is that we can produce cell types potentially to treat diseases for which we really don't have a curative type of treatment. Take type 1 diabetes. Patients are on insulin for a very, very, all their life, and there are many complications that go along with that. We know that you can transplant pancreatic islets from donor people who die into patients and get them off insulin for years. But we don't have enough pancreatic islets. Embryonic stem cells give you the potential to make those pancreatic islet cells in large quantities and potentially really treat large numbers of patients with type 1 diabetes. So that's the sort of promise that is out there and is coming down the road.
Are you specifically working on that in your lab?
No, I'm a stem cell biologist, but I'm really interested in just what a stem cell is and how they come from an embryo and what are the pathways that make a pluripotent cell special. And in my lab, in the mouse, we derive stem cells from that same early stage of development, but we derive stem cells that make the placenta, because pluripotent embryonic stem cells actually don't make the placenta. So we want to understand how those two cell types develop in the embryo. And actually what we'd like to do is make what we call a totipotent cell line, a cell line that could make everything, including the placenta, so that we could really model and study early embryonic development in the Petri dish and the placenta and find out what goes wrong in a lot of pregnancy disorders as well.
I don't know this for sure, but I'm betting you love your job.
I do. I mean, I think scientists have a passion. If you don't have a passion for what you're doing, why are you doing it? And I've worked on early embryonic development for all my career, and my lab is getting smaller and smaller these days. But the fact is that all the work that I've done over the years, other people are now still doing, and there are lots of new tools to study how embryos develop. And all the things we have said about stem cells could be used to help treat people are beginning to come to pass. So that's very satisfying.
That you love your job, it really shows. Dr. Rawson, it's awfully good of you to spend some time with us on TVO tonight. Dr. Janet Rawson, Hospital for Sick Children, Gairdner Foundation, all good wishes going forward.
Thank you very much, Steve.
Whether you've been tracking the development of COVID variants or tracking your ancestors, the genetic material used to do that work is considered gold in the biomedical industry. But once your DNA is in the lab, who owns it? And is the information gleaned from it safe? Let's ask. In North Vancouver, British Columbia, Tanya Bubala. She is the Dean of the Faculty of Health Sciences at Simon Fraser University, who researches health and biotechnology law and policy. And in the downtown of Ontario's capital city, there's Jim Woodgett, who is president and scientific director of the Terry Fox Research Institute and senior scientist based at the Lunenfeld Tannenbaum Research Institute at Sinai Health. And it's great to have you two on our program this evening. I want to just read a little excerpt from a magazine article that came out a few years ago by Timothy Caulfield and Blake Murdoch to set up our discussion. So here we go. We live in a fascinating and potentially precarious time, they write. On the one hand, there continues to be escalating growth, investment, and excitement surrounding biobanking. Across the globe, millions of individuals have been recruited to participate in these complex, expensive research platforms, and the potential scientific and health benefits are undoubtedly real. On the other hand, there remains a deep lack of clarity around basic legal and ethical principles. The public is supportive, but that support appears tentative and conditional on the maintenance of trust. And that's where we will pick up our discussion. And it's not just biobanks, obviously. We hand over our DNA all the time to commercial genealogy firms such as 23andMe, or to a lab for genetic testing, or we might be asked to take part in a medical study which requires this. So there's sort of myriad ways our genetic information is, quote unquote, out there. The question is, once it's out of our hands, Tanya, why don't you start on this? How secure is that information?
It depends on where you've sent it and who has it. And so I would say in Canada, in either a clinical context, so the data, who has the data, are the health authority custodians that are the data stewards of your genetic test results. So in the clinical context, or in the research context, sometimes that data is stored within a university in a research lab, and sometimes it is contributed to a larger initiative such as a biobank. In both of those contexts, the data are heavily protected by legislative frameworks, ethical principles controlled by research ethics boards. So there's a very strong governance framework. And I would say that the data is fairly well protected. When you send your data to a company, you need to read the fine print. And there it is a little bit of the Wild West, especially when you're sending it across the border to the United States or elsewhere. And there your data are far less protected, and you need to be aware of what the terms and conditions of the use and the storage of your data actually are.
Jim, I'll get you to weigh in on the same question.
Well, Tanya has answered it really well. The key word that she mentioned is custodian. So if you are submitting your data, for example, you're consenting to a clinical trial, or you're participating in a study, the healthcare institution or the university has to act as a custodian, which means they have to act in your interest to protect that data. And that's because the data is very valuable, but it also could potentially be used for uses which you hadn't consented to. So they need to make sure that any use of that tissue or that information is appropriate. And having said that, it's very important also when one consents and when one participates in these sorts of studies, you're asked to fill in what's called an informed consent form. Then what you should do is make sure that the consent form includes the appropriate information for that person to make the judgment as to whether or not they want to participate in the study. And we actually, as scientists, depend on the people, the citizens of the country, participating in these clinical studies, because otherwise we wouldn't make very significant progress in medical research. So it's a bargain, as it were. We need to keep the trust of the patients who are participating, and we also need to give them the security of that information that they're donating to us.
Well, that's prompted a follow-up, and Tanya, I'll put it to you. Custodian. If they're the custodian of, let's say, my information, does that mean they own it, or do I still own it?
Yeah, so this is a really interesting question. So property is a bargain, Jim used that word, between society and the property holder, and it's set up within a legal framework. So it's a three-way relationship between a thing or the property, the owner of the property, and the state that sets up the legal framework to enable the property ownership. And data doesn't really have one. So data falls within what we would call kind of this knowledge domain, which would fall under the legal constructs of intellectual property. And intellectual property covers specific things, and data in general would fall kind of under under copyright, right? So it's a thing. It's knowledge that is codified or sort of spelt out in text or in code. So it falls under copyright. But under copyright, data doesn't meet the definition of what is entitled to copyright. So it's this really weird thing in that no one really owns the data, but that doesn't take away the fact that you have an interest in it, because it is data that is about you, and it can affect your life, your finances. It can affect it's health information. It's integral to who you are, and you have an interest in it, but you don't own it. So nor does the doctor that collects it from you. So the way that the courts sort of think about it is in this weird area of law, it's kind of trust law, and they have a fiduciary obligation to protect it, because you have this inherent interest in it, because it's data about you and it affects you. So ownership is a shorthand, but in the legal sense, it really is much more about this custodial trust relationship, where you give up information about yourself, partly to be used for your benefit in a clinical context or in research that may benefit you or people like you, or to a company through a contractual relationship where in return you're getting services such as data about your ancestors.
Okay.
So it really is in this gray zone. It's a legal gray zone, right? But it's much more in this area of that Jim was talking about, this area of trust between the person and the custodian that's holding the data for your benefit.
Now, Jim, that's fascinating because, and maybe you could tell me how problematic you think it is that this really isn't 100% nailed down, this notion of ownership.
Well, I think one of the problems is that our hospitals, are given this responsibility to ensure that the data is kept secure and is appropriately used, and that can mean they can basically be ultra careful, too careful, and not want to share that data, even if it's in a very appropriate circumstance. And as we know, science really requires lots of collaboration and working between scientists and between institutions. And so one of the downsides of this is if it's overinterpreted, and typically you want to not do things, it's safer than doing things, then you can actually put in barriers which were unintended, and actually were unintended by the donors, by the patients who are providing the information in the first place. And so that can actually weaken the ability to do certain types of research and therefore have good outcomes.
Tanya, I may have this, as it was described, custodial relationship with, let's say, 23andMe, or with, let's say, a hospital that may be doing a research project and is using that kind of information for the benefit, I guess, of me and others. But what about, let's say, an insurance company that might want access to that information? Do I have that same kind of custodial relationship with them?
So that's very interesting. So Canada has relatively recently passed a Genetic Non-Discrimination Act. So it started off in about 2013. Senator Cowan brought that forward. It was finally made it through, passed as sort of a private member's bill in 2017. Quebec, of course, challenged it because we have this split jurisdiction in healthcare. Between the provinces and the federal government. And so they said that the federal government putting in laws about genetic information was overreach, that outside of their jurisdiction. It went all the way to the Supreme Court. The Supreme Court disagreed with Quebec and said that it was the proper use of the criminal law power of the federal government, because it was preventing a harm and it had incarceration or penalty in place. And there it prevents you having to give your genetic information in exchange for contracts, such as insurance contracts. So your employer and your insurer can't use your genetic information against you. That is your sequence information. But it exempts research and clinical uses. Now, there's a rub there, because the first thing that insurance companies do, of course, is collect your family history. So I ask you a really detailed questionnaire of not only about your health, but about the health of your parents, your siblings. And in essence, what they're doing there is collecting your genetic information without getting the code.
Well, but they're asking you, and you're presumably willingly giving that information, and you're presumably telling the truth when you give that information. Jim, I guess the difference here is that if you get the actual DNA sequencing, there's no fudging, right? You got it dead to rights there.
Yeah, absolutely. So each of us have, each of our cells has 3.1 billion so-called nucleotides, our genomic sequence, which can be easily put onto a USB drive. It's a tiny amount of information, but it describes, in essence, your genetic fingerprint. But you don't even need that level of detail. And as we've seen with companies like 23andMe and Ancestry.com, as has been the case in, for example, forensic determination of long unsolved murders, you can actually interpolate missing bits of information. So you can actually identify from, in cold cases, can identify genetic material collected at that time, and find the potential pool of the potential murderers. So I think that's a really important concept there, that you don't necessarily need all the complete information to actually be able to piece together sufficient information to identify a person, as long as you've got other information. And it's ironic in many respects when if I, for example, consent to submitting my genome to a public database for the public good, am I consenting just myself, or am I consenting my kids, their kids in the future? Because you can interpolate to a certain degree the genetic information which they're going to carry. And of course, that is recognized in the genomic sciences, and we are quite careful about that in the consenting, and forewarn people, and actually sometimes give them actually a quiz that they understand what they are actually consenting to. That's not necessarily the same with some of the commercial companies, and often they do have these end user agreements, like these software agreements, which are pages and pages long. And I don't think I've ever met anybody, apart from a lawyer maybe, and Tanya probably does this, who's actually read through these things. And so we often consent to things that we don't necessarily understand or appreciate what we're consenting to.
All right, let me circle back to something that Tanya said off the top, which is that often this information goes to, and I think you described it as sort of well-secured, ethically bound post-secondary institutions, for example, or commercial enterprises, which you said maybe just a little bit sketchier in the way that they follow all these rules. So I want to follow up on that. How are research studies, for example, governed to ensure that everybody acts ethically when they get this very personal, private information of yours?
Sure. So Jim has mentioned a few of these things. So the first things so for example, we're setting up a biobank right now with McGill University at the Montreal Neurological Institute for motor neuron diseases. So we are in the process of starting recruitment of individuals who have been diagnosed with a motor neuron disease to contribute their biological material and their health data to a biobank so that we can study motor neuron diseases for diagnostics and therapeutic development. So what do? Well, the first step in the process is an application for funding, and it's funded by Brain Canada, partnered with a couple of biotechnology companies and the patient organization. The next step in the process is to get the consent in place. This is a 15-page consent document that not only covers all of the sampling that is going to be done with these patients, but that covers what we call a consent to governance. So this is the consent for the process by which the samples are going to be governed in terms of how they're deposited, how they're stored, what they can be used for, who makes decisions about who can access them and for what purposes. And so it's quite a complex thing. And then after that, there are interinstitutional agreements between all of the institutions that are the clinical collection sites and the biobank. And then, of course, you want to look at sustainability beyond the terms of the study. These samples are hugely valuable, and you want to make sure that they're in a place that will live beyond the lifespan of the study so that they can be accessed and used for the purpose for which they were collected. And so all of that needs to be in the consenting documents approved by a research ethics board and heavily regulated within an institutional context.
Well, why don't we do a real life example here? Jim, you're with the Terry Fox Research Institute. You're overseeing the Marathon of Cancer Network. This is a study. What are you trying to find out?
Yes, it's actually the Marathon of Hope Cancer Center Network. And actually, so let me backtrack a little bit. We've got some fantastic cancer research centers in Canada, the Princess Margaret BC Cancer Agency, McGill Cancer Center, and many others. And each of those, a few years ago, realized that they don't see enough patients in order to get the statistical significance to answer key questions, such as, if there are small populations, subpopulations within patients who develop, for example, breast cancer, prostate cancer, et cetera, they don't see enough of those patients to be able to see the patterns in the information. And so they and we got together to try to form a national network between these various cancer centers. And that provided the opportunity to then significantly enhance the numbers of patients who will be involved in these studies. And we're actually working with support from the federal government to collect about 15,000 genomic profiles from patients with all different sorts of cancer, from childhood cancer through to pretty much any sort of cancer. And what we found over the past maybe 5-10 years is that even though you may have a particular cancer which is diagnosed in where it was found, for example, in a breast cancer, that a small fraction of those cancers actually look just have molecular defects, which are also found in other cancers from other tissues. And we have drugs against those. And so if you can identify the molecular lesion regardless of whether or not it's a brain cancer or a colon cancer or whatever, then that is often much more effective than using the typical generic type of treatment, the chemotherapy type treatment, which attacks the property of the cancer to divide. So normally cancers are threatening because they divide and they grow and they obstruct important organs and that sort of thing. So these molecular targeted drugs are much more effective in many respects. They have fewer side effects, and they're very targeted. The problem is that they are also quite rare, right? So we need to look at thousands of samples rather than a few hundred, which is typical in a clinical trial. So that required then the collaboration between institutions, between provinces across the country. And every institution, as we talked about right at the beginning, has a feeling that they need to, well, not a feeling, they have an obligation to protect the data that they have. And so this requires them then to make sure that for the benefit of the patients, the ultimate benefit of the patients, we are able to collaborate and exchange that data and that information. So the Marathon of Hope Network is really trying to pull together and have a common data bank, as it were, which is still highly protected, to allow those questions, those deeper questions, to be asked. And the way that we do that is by actually the data doesn't move. The data stays in those custodian centers, but we can query it using various appliances, data analysis appliances, and therefore we can maintain the safety, as it were, and the privacy associated with those data sets.
Gotcha. I'm going to read one more thing from that Caulfield Murdoch article, and then, Tanya, I'll get you to comment on this. This, again, goes back to the issue of trust. One of the key goals of biobanks is to produce technologies and drugs that will be used in the healthcare context. Industry will inevitably be involved, particularly as the work gets closer to clinical application. High maintenance costs mean that many biobanks must turn to industry for funding support, which some fear could affect the independence and integrity of research or result in changes in the use of data or samples that are inconsistent with existing consents. The inevitability of increased industry involvement creates the potential to erode public trust and to intensify the challenges associated with consent and sample ownership. Okay, Tanya, are there activities going on in the private sphere that have you concerned?
Yeah, so this is an issue because if we are going to develop new drugs and diagnostics, at some point there is the need for industry to be involved. They're the ones with the expertise, the commercial expertise, the expertise to take things through the regulators, the regulatory process, and the expertise in things like medicinal chemistry. We're not going to get scale up of things that are done in research institutions unless industry is a partner. And so again, it comes down to this notion of is that clear in the consent form that the samples that you are donating or that you are contributing to a resource will be involved, will be used, could be used by industry. We now have the capacity to get much more sophisticated about what consent looks like. Consent doesn't need to be a one-time decision point when your sample is put into a biobank. We now have the ability technologically to look at dynamic consent and to ensure that packets of information have their consent criteria attached to them. Do you want them used for this purpose, but not that purpose? Do you want them used by industry or not, right? So the other part of it is that it is incredibly essential to have patients as partners through the entire process. So, for example, for setting up the Terry Fox network, for setting up our biobank with ALS, the patients are partners in the governance process. So they need to be, part of the decision making along the way.
Okay, let's finish up on this. Joseph Urraqueta is an Indigenous American biomedical health disparities researcher. And he recently said this on CBC Radio. He said, "So just like we were exploited for land and crops, medicines and gold and oil, we will be exploited for the biological treasures that are in our genome. Jim, finish us up on this. What does he mean by that?
Well, I mean, historically, we had all sorts of examples of where researchers have gone into, for example, indigenous communities or remote communities. There's so-called helicopter science, where they've taken blood samples and other samples and then done some analysis, and they've learnt lots of information, but the communities from which they took that information didn't benefit. And in fact, there was no participation, there was no feedback. So nobody looped back and said, we found this, we found that you are a higher susceptibility. And what the remarkable thing is, I think this is why Canada is well positioned in terms of looking at the new targets, for example, for all sorts of not just cancer research, but cancer treatments, but also in other diseases, neurodegenerative and heart disease, for example. Our diversity, our population diversity is remarkable. And so we are a sampling of many genetic experiments, as it were, which are us. And that, of course, includes the indigenous populations. It includes the many immigrants who've come from around the world. And if we don't have them as part of the database, then we're not able to incorporate their learning, the learning from their genomes, but also they won't benefit. So the part of this which has been missed, I think, for many years, was that there was no reciprocal relationship. There was no benefit for those communities.
It's a fascinating topic, fraught with numerous pitfalls, which of course adds to why it is so fascinating. And I'm glad you two were able to spare some time for our viewers tonight to talk about this. Tanya Bubala at Simon Fraser University, Jim Woodgett at the Terry Fox Research Institute and Sinai Health. Good of you to spend so much time with us on TVO tonight. Many thanks.
Thank you.
Thank you.
Earlier this month, the World Health Organization honored a woman who was never given the respect she was due, but whose cells, taken without her consent, led to groundbreaking, life-saving medical advances for polio, cancer, HIV, and most recently, the COVID vaccines. Her name was Henrietta Lacks. She was a Black woman dying of cancer in 1950s America, and her legacy is hard to overstate. With us now for more in Baltimore, Maryland, her great-granddaughter, Victoria Baptiste. She is a nurse specializing in diabetic care and part of HeLa 100, the Henrietta Lacks Initiative, her family's year-long outreach and education campaign. It's an honor to meet you. Thank you so much for being on the show.
Thank you for having me.
And I recognize that for us, a lot of this information is new, but I also recognize that this is a painful experience for your family. And I just wanted to acknowledge that. Just to take us back to the beginning, how did your great-grandmother's cancer cells make it to labs around the world years after she had died?
So it's a bit of a mystery to most people how her cells have been able to live, so long outside of her body. Even here we are some 70 years later. Her cells, it was it was meant to do what it was supposed to do. That's the only real explanation I can give you, because the doctors who discovered her cells living outside the human body, they really didn't have an answer as to why her cells were able to live outside the human body as robustly as they did without needing as much nourishment that cells that we know today they require to be able to stay alive for us to do the research that we do on them. We do know that there were some medical things that made them special, like the place in which, the cancer landed on her, onto the cell, onto the tumor, and the way that it multiplied. I'm sure that has some effect as to why her cells are able to be this robust. But we really don't know, why her cells were able to do as much as they did as earlier on in science, without all the things that we know about, cell culture and things now.
Was your great-grandmother, Henrietta, did she give consent for them to take those cells?
No, and that's the part, like the research portion of it is what the injustice really is. They have like these, back then they say that, they had these blanket like consent forms. Well, yes, people consented for care, but they did not consent for research. So that's a totally different thing. So her tumor lesion was taken to the lab with the intent of trying to have these cells to live outside their body. It wasn't just her specifically that they were trying to find the cells to live outside the body for. They just knew that they needed that to be able to make any medical advancements for treatments in general. Hers just were the ones that were able to make that historic event, but it was not because she consented to do so. Now, had they asked her, I believe that she would have been willing to help science so other people wouldn't suffer the way that she has or she did. But she wasn't given that option. Was your family ever asked? No, our family didn't even know that her cells were still living and being used for decades later. After her cells had already been in research and already causing, medical advancements such as like the polio vaccine back then. We had no idea. What did that feel like to know that a part of your great-grandmother was being used in this way? Yes, it was being used to help people, but it was used in this way where her family didn't even know this was happening. That type of unethical type of way of procuring her cells was what the issue was. Our family's happy that our grandmother and great-grandmother cells have been able to help so many people, save so many lives, and even create lives through like in vitro fertilization. But that still doesn't, negate the fact that, this was such a gross ethical, unethical type of way of treatment. And we're still, we want to make sure that using a platform that we have today, that other people's family members don't have to go through that type of injustice today. How did you find out this was happening? It was actually by accident, by coincidence. My grandfather's wife at the time, Henrietta Lacks, was actually having lunch at a friend's house. And her friend's brother, I believe it was, came into the house. And after introductions were made, he said, "Lacks, that's not a very common name. Do you know a Henrietta Lacks?" And she told him, like, "That's my mother-in-law's name." And that's when he proceeded to tell her that, he worked at Hopkins, they had been using the cells in research. And that was like the first really official way by, us knowing that Hopkins was using her cells in research at that time. Later on, there would be, Rolling Stone articles and things that told us that the cells were being used, but no one ever came to the family and told them that, hey, we have these cells, we're using them. For research. They never asked for permission or consent. We definitely found out by accident. I think last year when the Black Lives Matter movement became a global movement, we started having these really necessary conversations, painful as they may be. I never found out about Katherine Johnson, who played a pivotal role with NASA in getting a person on the moon. And with your grandmother, her cells were pivotal in medical research. So explain to us, what are some of the medical breakthroughs that happened because of your great-grandmother's or HeLa cells? Well, first, I wanted to just mention, since you mentioned outer space, her cells actually did go into outer space to test what 0-degree gravity would do for human cells. But recently, well, let's start back at the beginning. Her cells were made it possible for polio vaccinations, again, for in vitro fertilization, for a lot of our insulin that we have now for diabetic patients, for as recently as the HPV vaccine and the COVID-19 vaccines are just a few of the medical advancements that have been been able to be because of her cells.
Which is incredible. The WHO recently honored your Henrietta Lacks, and to think that during this pandemic, we know that the Black community has really been impacted by COVID, and then to find out that these HeLa cells came from a Black woman. How does that, what impact does that have on your family to know that your family is part of history? Many histories.
For our family, it just solidifies. Yes, my great grandmother did just. We just were able to get an award on her behalf. It was from the WHO. It was the Directors General Award, which had never been given to anybody, especially somebody that had already passed away, that's been able to create these medical advancements. But for our family, knowing the background of what our loved one had went through, what Henrietta went through, it's just made it more solidified our causes to, one, take back our family's narrative, for us to speak our truth ourselves, and to try to make sure that other people don't have to go through this type of injustice again. We're using this as a way to fuel us to do something positive, trying to help combat health equity issues, social injustices, especially in medicine, that we still see that today. We don't want to believe that those things still happen, but they do. We want to educate patients on what their options are in healthcare, that you don't have to just go see one physician and just take that physician's word for it. You do have a right to a second opinion. You do have a right to your medical record. So we want patients to know what their rights are, what their options are, because no one took that time to have those conversations with our loved one, with Henrietta, back then. Our family is also partnering up with people like, with companies like the WHO and our sisters out here fighting cancer. We just had some meetings with a few of the first ladies of Nigeria, because our family is really passionate about trying to eliminate cervical cancer, because we know that it is possible if we can, get more education out there about HPV and how important it is to be vaccinated, not just for young women, but also for young men. We can we can eradicate cervical cancer that way. So the injustice that happened to our loved one is just helping us to fuel some positivity, so we can ensure that these type of injustices don't continue on in our time.
And I should just mention that Henrietta died from cervical cancer. So in a way, it's a full circle moment. And her cells, as we mentioned, they weren't just shared, they were actually sold. Do you know how much profit they have generated?
I don't think anybody can tell you exact numbers, but I will tell you that a multi-billion-dollar industry was cultivated from her cells. We have big pharma and all that good stuff that came about because of her cells, because of the research they were able to do and the advancements they were able to create from using her cells. So I know upwards of billions and billions of dollars.
Well, I know that in the UK, there's a statue that was done in honor of her, and the honor from the WHO. But a lot of people have said, have asked this question: why hasn't your family received financial restitution, or have you?
Our family definitely has not received any financial restitution. Why? There are a plethora of reasons why, but I think that's more of a question that we need to ask the companies that have been able to monetarily benefit from our loved ones' cells over these 70 some years, as to why the family hasn't been compensated, because we don't know why. There hasn't been any offering of anything or having conversations as to, we know that we've made these, this type of money off of your loved one's cell. What can we do? We haven't had any of those type of conversations. So why is a good question. And we would like to know the answer to that as well.
Well, to prevent this from happening to someone else, have laws or ethics changed so this doesn't happen again?
Some things are like, again, our family is trying to reclaim our story, our narrative. And part of that is so that we can help people so that they won't go through these things that we went through. We have the Henrietta Lacks Enhancing Cancer Research Act to the study that was funded by the government, clinical trials, including the NIH. It's a long overdue step towards diversifying clinical trials. That's one of the things that has changed that we've been able to do with that Henrietta Lacks Enhancing Cancer Research Act. We know that we need more representation for people of color in research because we are predisposed to certain things that other ethnicities are not. So if we're not represented in these clinical trials, we can't have that type of medication that's geared specifically to us. So we're advocating to get more representation and diversification in research as well. And that's something that's came about, after this, everybody else is starting to learn about our great-grandmother and all the great things she's done. Those are just some of the things that have changed so far.
Well, in our final moment here, your great-grandmother has been written about. Oprah made a movie about her story. But what was she really like, as you have been told?
From what I've been told, she was definitely a pioneer of activism in the community. I say that because she helped a lot of families matriculate from Virginia up to Maryland so they can have better jobs and create better lives for their families. I was told that she loved to dance, she loved music, and she loved to dress nicely. But above all that, she was just a caring, loving person. And I think that is the biggest part of her legacy that the rest of us are taking with us. And that's a part of the reason why we have this HeLa 100 Henrietta Lacks initiative that you can check out at HeLa100.org. We're just the families initiatives all in one place that we're trying to fight and advocate for that for health equity and to try to right some of the wrongs that happened to our great-grandmother.
Victoria, thank you so much for spending some time with us. It's been really nice having you on the show to understand a little bit more about who she was as an individual. And of course, thank you for all that she's done. It doesn't feel quite enough. It's been a pleasure having you on, Victoria. Thank you so much.
Thank you.
And that is the agenda for Monday, October 25th, 2021. The Toronto Transit Commission is 100 years old this year. Tomorrow, we'll look into how it's doing after the massive hit from COVID-19 disruptions. I'm Steve Paikin. Thanks for watching TVO, for joining us online at tvo.org, and we'll see you again tomorrow.
The Agenda with Steve Paikin is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.